Thermite is a very active chemical reaction. It produces molten iron spheres. The spheres you get from thermite matches the spheres that I see in the World Trade Center dust.
The dust he found contains iron oxide and aluminium. So does thermite.
What do you think? I would say that it melted out the whole side. I went right through the aluminum, of course, I should have. So as the thermite reacts, it blows molten iron into the air, where it forms droplets due to surface tension, and then those solidify and form these little spheres.
These iron-rich spheres can only be formed at very high temperatures. Stephen Jones says the fires in the buildings before their collapse were not hot enough. Only a thermite reaction could have made them. But official investigators say these spheres could have been formed in the fires in the rubble after the collapse of the buildings. Debris can trap heat and lead to long-lasting and very hot fires. They also say that the ingredients found in thermite are not unusual.
Iron oxide and aluminum are very common materials. They are used extensively in buildings. So the fact that aluminum and iron combine together in a chemical reaction under heat is not at all surprising.
Hold on. Even if NIST are right, that wouldn't explain the iron microspheres in the dust samples that weren't even from the debris part.
When the South Tower collapsed and blew into my apartment directly across from the World Trade Center, I saved the dust. I gave it to Stephen Jones.
The dust that was provided by Mrs. McKinley is very interesting because it's like a snapshot of the residue being produced by the tower during its collapse. It's perfect. Now we look in the dust and we see metal droplets.
Stephen Jones is undaunted. He thinks these red chips in the dust could be evidence of unreacted thermite.
All of them.
Chips that are 1/16 of an inch long, that have the unignited thermite in them. This is high-tech stuff, nano-sized particles of iron and aluminum. This is not a product that's found in any office whatsoever. We have, again, potassium, manganese, iron, aluminum, and this is extremely explosive stuff that's found by, that's only recently been produced in papers by Lawrence Livermore Lab, Los Alamos. This stuff is not made in a cave in Afghanistan. We know the source of the iron-rich microspheres because they're partially attached to these tiny chips found in every sampling of dust that Dr. Jones and others have found now.
Glad to address that, Richard. You're right. They're not made, these chips of that iron-bearing material are not made in a cave in Afghanistan. They're made in Pittsburgh, Pennsylvania by the Pittsburgh Paint Company. They're made in Kansas City, Missouri by the Tnemec Paint Company.
Paint?
So I took one of these red chips and had a friend scan. It's hard to get thermite to ignite. And I thought, how can we tell if this is thermite or not? It's not easy. It has the right chemical signature. Aluminum, iron, oxygen is what you need. And it's got some other goodies thrown in, silicon and potassium. And so typically, I put the K in parentheses. Not all of these show much potassium. But anyway, that's the signature. And so a friend of mine has an oxyacetylene torch with a very fine tip. He uses it for repairing eyeglasses. And so I had him pass it over one of these red chips. It was just 1/32 of an inch on a side, approximately square, and it flamed, it flashed as he passed over it. Now that's not itself a proof, but it's a strong indication, along with the chemical composition and the red color, which indicates iron oxide, that this is a form of thermite. I've provided red chip samples now to an independent laboratory for testing with the question to them, do they agree, do they find that these red chips are a form of thermite? The technical term is aluminothermic. Independently, Justin Keough and his team, I know he's working with Richard Gage, is now also looking at the World Trade Center dust spheres and red chips also. Excited to say. Richard called up Justin last night. I talked to him on the phone. Oh yeah, we saw some of that red stuff, you know. He said we tried it in a Raman spectrograph system analysis. And he said we hit it with a laser. Now this stuff is behaving like thermite, folks.
That's why they're extremely explosive, I suppose.
One thing that should ring a bell is that they look exactly like all the primer paint that's on the structural steel.
So apparently there was high-tech, highly explosive aluminothermic primer paint on all of the structural steel. Interesting.